Hello, friends. How's it going? Good morning. Good evening. Okay, I think we should be fine. So, thank you guys for joining today. My laptop broke, and since it happened to be Easter, it took like a few days to fix. So, this is actually another laptop that I'm using now. So, fingers crossed, everybody, that we can get through this live stream and have it still work properly. How are you guys doing, friends? We are going to be covering a lot of things today. Oh, let me mute myself. Good morning. Oh, hey, Rex. Hello, friends. Wow. Thank you for waking up early for this, and happy Easter to anybody that is celebrating. Did you step on your laptop? No, it was so random. It literally just the screen went black, like suddenly. I think maybe it was because I dropped it like 2 days ago or something like that, and then it just decided to go black. And I'm like, shit. And it was literally 1 hour before the live stream. I'm like, there's no way. Because it was also like 7 a.m. and it was on Easter as well. So I was like, there's no way I can manage to find another laptop within a span of an hour. So that is fine. Okay, without further ado, let's actually get started because I have a lot of things that I want to cover today. And thank you all so much for joining. Okay. All right, so today I'm going to be talking about details about building AI agents. In terms of, first, we're going to talk about agent components. So pretty much like a little bit of theory again. I think a lot of people, an issue that they run into when they're building AI agents is that they don't really think very carefully about exactly what it is that they're building first. So they just start like building like things and then it doesn't work and they're like, oh shit, it doesn't work. So I'm actually going to talk about like what are the components to think about how to build your AI agents, and then also like what kind of patterns, like pre-existing patterns. There's been a lot of pre-existing patterns that people have used already. So how do you like decide the thing that you're trying to build and match it to the best pre-existing pattern and then implement that. So in this case, you can implement it using code. You can also implement it using no code. I actually think the implementation step is really not the most important step, but it's what people tend to focus on the most because it's like the most visual part, right? Like when you're actually building it. But it's quite important to actually think through what it is that you're building before you actually build the thing. And I want to actually show you guys like a few demos. First up, yeah, because I don't know if I have time. I want to make sure I have like time to actually show you some of these demos. So the implementations that I did, I'm going to show you are using NA10. I also do have some implementations that I did using OpenAI's Agents SDK. Let me know if you guys have used Agents SDK or NA10 before. Put in the comments. Agents SDK, like I'll talk a little bit more detail about like exactly how they're different. But I like if you I really recommend using more of a coded version just because it's a lot cheaper, first of all. And then a lot of like things that are, there's a lot of limitations to no code tools like NA10. But again, I'm going to show you guys most of these examples in NA10 because it's the most accessible to most people. But yeah, the other ones I've done, if I don't have time to go through the code examples, I can link that in the email that I send out to you guys afterwards with all the slides and stuff. So I'm going to show you the NA10 examples first. For some of the things that you can build. Let me see what you guys are saying. Agents SDK, no. Everybody okay? I am good. Always have more than one computer. Man, I don't have more than one computer. Do people really have more than one computer? I don't have more than one computer. I like have like half a computer now actually. So there you go. Okay. So, let me show you like a couple examples of some of the workflows that you can build using if you actually like build it correctly. Where did I put it? Ah, yes, okay, there it is. Okay, oh no, do I want to save it? Yeah, probably. I probably want to save stuff, that is true. You know what? Let's just not, okay, no, we should definitely save it. Okay, it's gonna YOLO it. No. Okay, make this go away. Can you guys see my screen? Okay, cool. You can, I think. How are you likely? Let's say like 8. Okay, no, go away. Okay, so here's an example that you can build using NA10. So what you can do here, this is actually like a schedule trigger. This is an AI news aggregator, and this is something that I really hope we have a little bit of time. I want to actually like show you how to build like components of this, but I'm gonna run it for you first. So this, you schedule a trigger at 7 a.m. and then you want it to be able to aggregate news from Twitter, from X. This is from like newsletters that you're subscribed to. And then here is from like Reddit. For example, since I'm in the AI space, I need to aggregate, like I need to know things about the AI space, but I don't want to, have to go do it myself. So I aggregate all this information together from these different sources. Here's the aggregator. And then I would summarize this and actually message, it should send me a message at 7 a.m. on WhatsApp with all the information that's there and all the information that is linked out as well. So here's the moment of truth if it actually works. Okay. Okay, so we're just running it right now and it should show up on WhatsApp here. We shall see if it shows up or not. Oh, you never know. Whenever you do live demos, something often goes wrong. And by the way, this is an example of a workflow that's called parallelization. You can see that there's parallel streams that are happening right now. Although like actually that's one of the limitations of NA10. It doesn't actually run things in parallel, but if you're using like code, for example, this should be like running things in parallel, and this is a implementation of parallelization. So just kind of like a little heads up, we're going to be going through like different types of patterns in a bit. Now we wait patiently. Actually, you know what? Oh, okay. It's almost done. Cool. I was gonna say if it doesn't work, then we can go do something else first. Ah, shit. Authorization failed. Of course it did. Okay, let me see if I can fix this with a new code. If it doesn't work. Okay, I'm just gonna input a new code, which I'm running it again. Aren't live demos wonderful? Okay. So here, what's up? Okay, I'm gonna, oh shit, yeah, I'm gonna not screen share this bit just because I don't know if I'm gonna leak a API key or something like that, but give me one moment. How do I do this? I kind of, shoot. Literally just did this earlier and I don't know what happened. Of course. Okay, credential setup, error fetching. Okay, you guys chill out for like a minute while I try to figure this out. Where do I'm gonna go ask ChatGPT because I forgot how to re-enter the code for this. Okay, I'm changing an access token. Okay, that should work, and it usually takes around like 5 to 10 minutes for it to actually activate. So we're gonna let that chill out for a little bit. until you can manage to get it to work again. Okay, yeah. Also, one of the limitations of using NA10, as you guys have just witnessed now, it's the fact that you get a lot of like these little things that could potentially break while if you're using code, for example, because you store things in code. Generally speaking, you don't usually end up having these like stupid issues like authentication keys that you need to refresh every hour, which is the case for the WhatsApp key here. Anyways, okay. I'm gonna try, let's actually go through the rest of the PowerPoint slide. I'm gonna try running it again in like 10 minutes because it takes like 10 minutes just to populate when you're using a no-code tool like NA10. Okay, so see if anybody has any confusions thus far. So real. ChatGPT is our savior. Yeah, so I'm gonna wait now another 10 minutes, but I'm actually gonna go through the rest of the slides first before I can show you guys the demo. Okay, so what's important to note, and what you saw there was like an example of a different workflow, but I want to actually, I want to go through like what you should be thinking about when you're actually building an AI agent, right? So the first thing before you just go ahead and go build something, you want to actually like understand what are the components that make up an AI agent. And this is something that I was mostly inspired from this definition from OpenAI. A lot of different companies will define like what components go into an AI agent differently. And because it's like such a new thing, right? But I actually really like OpenAI's definition of what are the components that make up an AI agent. And like, of course, just to kind of recap that, an AI agent is usually something that is able to autonomously or semi-autonomously perform a certain task and work towards a certain goal. So usually when we think about AI agents, you usually think about them as like some sort of role agent. So it's like customer service AI agent, where, you know, what I was trying to show you guys earlier was like an AI news aggregator or AI news aggregator summarizer AI agent. So you usually think about it like a certain task or a goal or a certain role that the AI agent encompasses. And it should be able to do this using different components that it has. And these are the different components that go into making an AI agent. Think of it like kind of like building, if you have like a burger, for example, like you can switch out different things. Like you have a burger, you always have like a bun, a patty, I don't know, like vegetables and condiments, but you can switch out the different types of bun. You can have like whole wheat bun versus white wheat, white bread bun. You can have like turkey bun versus like turkey patty versus like beef patty, vegetable, I don't know, like onions and tomatoes, as opposed to, what else do people put on burgers? Other vegetables. I can't think, lettuce, yes. Or like, you know, types of condiments. But you see how like you kind of need all these components to be able to make sure that you have a well-formed burger. So it's very similar. When it comes to an AI agent, you need to have like these certain components that you kind of like mix and match, switch them out. You can eliminate some of them you can't eliminate. And if you put them all together, it should make up an AI agent. So what are the components of an AI agent? First of all, you need to have the model. So this is like the non-negotiable part, right? Like you need to have a model if you're trying to build an AI agent. And this, in obviously like with ChatGPT's, like with OpenAI's case, they give you like their own primitives for this. And that's actually why like I made this slide over here, because I wanted to also add in like different alternatives. So, oops, can you guys still see what is happening here? Okay. I hope you guys can still see that. I think you can. Yeah, that's good enough. Okay, so for models, you can have like OpenAI models, but you can also have like different open source models. You can choose like Llama 3 if you want open source, Mistral, Claude. Claude is not open source, but you can also use Claude if you're trying to create an agent that's more specific towards like reasoning or STEM or coding kind of subjects. If you want to create an AI agent, you're doing something that you want it to be, sorry, it's like a fluff. If you want it to be like a fast, so like whatever it is you want to do, if you want it to function really quickly, you usually want to go for like smaller models. While if you want something that's more thorough, you want to go for bigger models that are more like robust and able to like think through things, thinking models that will take a longer time, but it would have better answers. Other types of models, like if you're going for something that you want a really big context window for, you can also look at Gemini, for example. I think OpenAI, yeah, like also released another model that has a really long context window. So whenever it is you want to think about when you're choosing a model, think about what are the certain capabilities you want your AI agent to have in order to choose a certain model. And then the next component that you want to think about is tools. Depending on the agent that you're trying to build, you want to equip it with different types of tools. So tools allow you to interface to the world, interact with the environment, function calling, built-in tools, etc. OpenAI again has like its own thing, and that's why when you use like OpenAI's Agents SDK, it kind of gives you access to all these things. But there's other alternatives that you can use as well. And tools are things like that allow you to access the internet, for example, right? Like you can do API access to like Gmail or Slack. You have MCP. So MCP is something that is relatively recent, but it's basically like a protocol. This is not actually modular control pipeline. That is not correct. That is not what MCP stands for. I'm pretty sure it's modular. Pretty sure it's a protocol. See, now I gotta look it up again because I can't remember what MCP actually stands for. Model context protocol. So ignore that part. I'll fix that later. This is a way, like having a model context protocol is going to allow you, it's a protocol that allows you to be able to equip your agents with a lot of different tools much more easily. So this is something that's like a very innovative thing that you might have seen everybody on social media talk about. And it really is quite revolutionary. Because previously trying to equip your agent with different types of tools used to be such a pain in the ass, mostly because different like APIs, different tools, they all have like different ways of accessing it. But MCP is a way of trying to standardize that. So you're able to give it different types of tools and define it in a very similar way. I also want to say, by the way, like if you're building things through code, these are things that, you have more control over. You get to choose this a lot more easily. If you're using things like NADent, where like no code tools, a lot of times like you don't get as much choices in terms of what it is that you're doing. But I think it's still important for you to actually know what these components are before you actually build it. See if anybody has any questions so far. Oh yeah, if you want the slides, here, I'll send you this thing over here. Here, you can sign up there and I'll email you the slides afterwards with all this. Drop in the comments, just type the word components, like components, if it makes sense as to what I tried to explain about why it is that you have these different components. Just write the word components to see if you guys are paying attention. Okay, I'm gonna keep going on in the meantime. So the next component that you want to think about is knowledge and memory. Depending on the type of AI agent that you want to build, you might want to augment it with different types of knowledge and memory. So there's actually two different types. The first one is static knowledge, and this is just information that you want it to have and it can reference. For example, if you're building like an AI agent that is like a law AI agent, right? Like you wanted to go through a lot of law documentation and like go through a lot of cases, for example. Probably whatever it is that the agent was trained on did not include your private law cases. So you can do something so you can provide that knowledge base to your AI agent so it's able to access all those law cases while it's screening through it. So there's a way of doing this through OpenAI. They have vector stores, file search, and embeddings, but there's other ways that you can do that outside of the OpenAI ecosystem as well. It's usually in the form of RAG and vector databases. And another type of memory is considered dynamic memory. So this is, for example, if you're trying to build something that's like a mental health, like I don't know, like a psychologist AI agent, right? And you're probably your user is going to have like multiple conversations with your psychologist AI agent, and you want to make sure that between the sessions that the user is like speaking to the psychologist AI agent, the AI agent is able to remember all of the conversations from previous, so it's able to continue to have that context. This is also something that you can build into your AI agent depending on your use case. And again, like OpenAI kind of has its own like versions of these, but you can also there's other like open source ways of doing it, like Weaviate, for example, and other ways that you can implement this type of dynamic memory as well. Let's see if anybody has any comments. Oh, thank you so much, Rispargu, for supporting the channel. Components. Okay, great. Wonderful. Thank you. Thank you. Makes sense. Okay, cool. Let's some questions. I think I'm confused on why these things are necessary. I think I understand what the components are. Okay, that's a great question. Because when you're building an agent, it's sort of like, why are they necessary? Well, for example, if you don't have a model, then the agent itself would not exist, right? So you have to choose a model. And like tools, for example, like if you're trying to build an AI agent that is able to search the internet, right? Like the AI search news aggregator that I will show you guys later. You need to give it tools like being able to search the internet, because if you don't give it that, how is it supposed to be able to search the internet, right? Or like be able to access like different API points on Reddit or like X, for example. So when you're creating whatever it is that you have in mind, you need to think about which are the components that make the most sense for you to build what it is that you're trying to build. Yeah, that is why these components are important. Obviously, like not all of them are important, like as important, and also not all of them are completely necessary. Like sometimes if you're trying to build something that's like, maybe you don't need static memory, right? Like maybe you're just having like one-off conversations with some sort of agent, like I don't know what kind of agent. Like your AI agent just needs to just chat with you about something that it can access, and you don't need to provide it with memory. And maybe it's like a one-off situation. So maybe the agent that you're trying to build, you don't need to have dynamic memory being as implemented into the agent, because it doesn't need to retain information between different sessions. Okay, so the next one is audio and speech. This one is much more not necessary, but I think it really is something that there's a lot of innovation in, which is also why I think OpenAI actually puts this as its own separate component because of audio and speech capabilities now. So this is something that if you're trying to create an AI agent, maybe like a psychologist or a therapist AI agent, you want to allow your user to speak to your agent using natural language, like just like speaking directly, then you would want to implement a component that has an audio and speech feature. Yeah, here's like some of the other ones. I'll try to go through this more quickly because we have a lot to get through. Yeah, and then the last two, I actually really like how they included this. A lot of different other resources don't include it. So guardrails and orchestration. So guardrails is after you release your AI agent into the wild, you probably care about what it's going to say. Like, what if it goes rogue? What if it says something ridiculous that you probably don't want it to say, right? So there are certain things that you should implement into your AI agent as guardrails. Like if certain topics come up, right, where it becomes like irrelevant in some way, or like certain test cases that you want to implement. So you want to constantly be checking that your AI agent is not going rogue. If you have like a pizza ordering AI agent, right, that's like supposed to help you order your pizza, you don't want it to suddenly give you advice about life, probably. So you want to make sure that you're putting in different guardrails so that it's doing what it's supposed to be doing over time. And yeah, there's ways of doing this within OpenAI as well. And then there's also like, here are some ways that you can do it outside of the OpenAI ecosystem. Finally, orchestration. So this is actually we're going to go into more detail about, which is the actual like way that you are actually putting together your AI agent workflow. So a lot of the times an AI agent, when we say it's like an AI agent, like an AI news aggregator agent, right? It's actually not a single agent that does everything. It's actually divided into sub agents. So you have like sub agents that would do something, and then ultimately you compile everything together. Like all the sub agents do whatever it is that they're supposed to do, and they actually all come together to be able to come up with the final result. And we kind of call this entire system an AI agent, when in reality, it's more of like a multi-agent system that we just refer to it as an entire system. And if you are wondering, like, why is it that we need to divide like an AI agent's role into so many different sub-agents? It's quite similar to how you would think about like people, right? If you're running a company, like you're running like a news company, right? You probably don't have like one single person trying to aggregate the news from like X, also doing the same thing from like newsletters, right? And then like having to do like all these different things, compile it all together, write everything, and then publish everything as well. If you had like one person do this, that person will likely get really confused and also be like, not know how to orchestrate, like not know how to prioritize what it is that it's supposed to be doing. So similarly, like with AI agents, if you just tell one AI agent to do everything for you, and if the scope of the work is too big, it's going to start getting confused. It's going to be like, I'm not really sure which one I should prioritize. And then like it forgets certain parts of it. And then, if maybe like it puts it together in a really weird way. So that's why you also want to divide your AI agents oftentimes into multi-agent systems. And orchestration is how it is that you should be able to put these systems together, because you also don't want to just like randomly put a bunch of sub agents and go like, figure it out, guys, you know, work with each other or something like that. You do want to provide us some structure in terms of how it is that these AI agents, these sub AI agents are working together to come up with the final result. And these are some of the, there's like some common patterns that people would use for certain types of tasks that has been proven to work the best. Part of orchestration also involves like the deployment and the monitoring and the improving of the agents over time as well. So yeah, so here are like some ways that people do it, like Crew-AI, LangChain, Llama Index. A lot of these like orchestration systems depends on factors, like for example, like Llama Index is particularly useful if you're creating a multi-agent system that is good for document-based RAG and knowledge system. So it's like things that are very knowledge heavy. Llama Index is a really great choice. Crew-AI is a really great choice if you want to just get something to work really quickly and then get it to just get out. And then it's also really easy to stack different sub-agents together, while LangChain usually has like a higher learning curve. So there's a lot of different options depending on how it is that you want to orchestrate as well. And again, all of these components, a lot of no-code tools don't really give you as much freedom in terms of choosing how it is that you're putting things together. While for like more, if you're coding these things, then it's even more important for you to realize that these are the components that you should consider whenever you're creating an AI agent and how it is that you're putting it all together. Okay. Let me see if anybody has any comments or questions. I'm going to try running this again as well. See if it works. Any questions or comments about whatever it is that I just talked about? Please work. I'm going to be so sad if this live demo doesn't work. What cases we wouldn't need static memory? If it's something that it's already trained on, like you don't have additional information that is required. Like for example, if you have, let's think. I'm trying to think. Okay, so for example, if you want to have a agent that is just like conversing with you like through the web, right? Like it doesn't need to have additional information, like a pizza builder agent, for example, right? Like you probably don't need to have a static memory system because it's able to have access to the information of like whatever is on the pizza website already. So some customer service agents, like if they're not really advanced customer service agents, you wouldn't need to have static memory to the, obviously if you have like very specialized things, maybe it needs to have like documentation about the company or something like that, then you would need to have an AI agent that has access to static memory. That's what I can come up with right now. Can't really think of another example. Oh, another one. Okay, yeah, like translator AI agents generally don't need to have static memory as well, because a lot of, if you're translating between like English and Spanish, you don't really need to have that information externally, since the model was probably trained on all the information that it needed to do the translation already. So that's another example where you don't need static memory. How to choose the right model? Great question. We actually did have a live stream about that last time. But yeah, choosing the right model, I kind of went through that a little bit earlier as well. So depending on what you value, like do you value speed, then you probably want to go for a smaller model. If you want value about having like the most robust answers, you want to probably go for a bigger model. Do you care about privacy? Probably you want to go for a open source model. If you care about like something that's very good at coding or STEM specifically, you probably want to go for a model like Gemini or Anthropic. Or Claude specifically. So there's a lot of different like models that you can choose from. I would recommend that you check out this website called Vellum. I don't know how to pronounce this website, but if you check out Vellum, it is a leaderboard sort of thing. So it kind of tells you like top models by task, like different evals, whatever. Maybe you want to make like something that's really good at high school math for some reason, then you can choose like which model works the best for you. So this is like a great way to start in terms of choosing which model you want to have. Did it work? Please work. Oh, it said it worked. Yay! It worked. Okay, let me explain. Let's actually go through some of these demos now before I move on to the... Ooh, actually, put in the comments, do you want me to go through the agentic systems first, or do you want to feel excited and look at the demos first? Would you like to have... Oh, that's a great question. It's a psychology question, guys. Are you guys the kind of people, would you like to have delayed gratification, which will increase your understanding, or would you like to have instant gratification and see the cool demos first? Delayed gratification with more understanding and learning, or instant gratification? Write in the comments. Demo first. Oh, you guys are so, are definitely instant gratification people. Got it. Y'all are instant. Okay, we have a few delayed gratification. Delayed gratification. Instant. That's pretty funny. Okay, I'll show you guys the demos. And I will give you an example. Okay, it does look like we have more instant gratification type people. I swear this is probably very insightful in terms of such informations. But let's do instant gratification first, and then I'll explain the demos later. Okay, guys. Your word is my command. Okay, so we just did this as I was saying earlier. This schedule a trigger by just like, it's supposed to go out at 7 a.m. but I just like triggered it immediately and aggregates all the information together with different AI agents. This one is like from Twitter, from X. So it takes all the things from X, and then over here it searches the keywords based upon the newsletters that I'm subscribed to. This is an AI agent that has access to my email, and after it has access to my email, it would screen for certain keywords related to AI news and also by like a certain time frame. And you can actually I have like a prompt that is based here as well, so I can kind of quickly show you that. So this is like a certain type. Whenever I do like prompting for AI agents, I usually follow this framework, which, since you guys chose instant gratification, I'm not going to go through this right now. I can go through it a little bit later when it makes sense. So it's just defining like what it is supposed to do. In this case, the AI agent is supposed to just go and get like a specific AI search term provided by the newsletter Mindstream, and you can obviously add like different other newsletters that you're subscribed to as well. And the model here is like OpenAI's chat model. So you have GPT-4o mini in this situation. So GPT-4o mini will go through my email and find the newsletters related to the search term that I'm interested in, which is AI news. And then on the Reddit side, goes on Reddit, searches the subreddit. In this case, the subreddit, you can also see the prompt here, is from artificial intelligence subreddit, and also searches the recent posts in order to get information. And then it aggregates all of it together to send me a message on WhatsApp, which is here. We just showed over here. Okay, so blah blah blah, latest in artificial intelligence, 8:33. Okay, cool. All right, so AI generated art at the Met Gala. Interesting. OpenAI's new chatbot update. So there's more information here. There's AI in healthcare, revolutionizing diagnostics, AI-driven climate solutions, security concerns over AI surveillance, blah, 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 right? So it has like all these things that are summarized based upon those 3 different streams of information coming in. And it would send me this WhatsApp message for me to like look into more if I want to. And then there's also like links that are here as well. So like, I don't know, I'm so interested in something specific, then I can actually click in and learn more about this. So this is a great way for you to catch up on your news and have it be very, very specific to what you're interested in, as opposed to having to like read a lot of things at the same time. All right, I'll show you guys another demo. Let's save this too. I'll show you guys another demo as well. I like this one. This one's pretty cool, actually. Okay, so this is a multi-input daily expenses tracker. So what it does is that, I will just show you on WhatsApp, I can do something like have like a receipt, right? Like I can drop in a receipt that I spent on the grocery store. Like I have like this problem where I'm not very good at tracking my money, and I'm too lazy to actually like input what it is that I'm tracking. So we can make this workflow. Oh, sorry, I forgot to start it. So I'm gonna do it again. So you can like take a picture of the receipt at the store and just directly send it on WhatsApp as well. Waiting for trigger event. Okay, and then it executes. Things that are here, it's able to execute. It tracks the information in memory here, so you do have static memory, so it's able to track everything. And then throughout the day, like maybe I would just also want to say something like, I bought a muffin for $5, right? And then it would like continuously just like track that as well. So obviously like I have to execute it here because I haven't deployed this yet, but it would, you know, track that information as well. So okay, I forgot to. So yeah, so like throughout the day I can just like message it and tell it things that I bought, how it is I'm spending my money, blah blah blah, all of these different things. And then, you know, if maybe for some reason that's like all I ate, or I just bought a muffin and I went to the supermarket, then you can do something like, this is a scheduled trigger. So technically this should only trigger at night. So it would send me a summary of the amount of money that I spent, like what it is that I spent my money on. And here it's accessing a database where it stored all that information. And then it would do something like, message me on WhatsApp telling me about my spending behavior. Today, Tina's spending primarily focused on living expenses. Okay. With a particular emphasis on grocery items such as organic milk and free-range eggs, each bought twice, suggesting a preference for organic products. The most notable expenditure was on Starbucks French roast coffee. So this is what the what was on the receipt. So you can actually see that it was in fact accurate. So this is the receipt that I showed, right? The eggs, the organic milk, as well as the French roast that is here. Which she also purchased twice. Oh, okay, I see. So it says I purchased it twice because I sent it 2 times. I was just being impatient, but actually I only purchased it 1 time. You would not message it multiple times, but yeah, anyways, purchase twice, underscoring a reoccurring fondness for the particular brand. Apart from her grocery shopping, Tina indulged in a little bit of leisure with the purchase of a muffin. Overall, her purchases indicate a balance between essential living expenses and small personal treats. Isn't that pretty cool? Let's see in the comments. Is this a sponsor? No, it is not a sponsor. Just FYI, I always disclose all sponsors. And this live stream is not sponsored. Yeah. Yeah, I think it's pretty cool. And then you can like, you can type stuff. You can also do like a voice, different things as well if you want. You can also take pictures of just like the food, and then you can write like bananas for $2 or something like that, and it would be able to track everything and then just tell you at night and just give you like a record of your spending behavior through WhatsApp, which is good to know. You know, maybe you like bought 20 pizzas, you're like, shit, maybe I shouldn't have done that, you know. Cool. Okay, so there is one more demo, but I might actually save that for my delayed gratification group of people who are instantly gratified instead. But maybe I'll show you guys the last demo after I go through the rest of these. So yeah, these are the kind of things that you can build using N8N. Honestly, if you did them using code, it would be actually like it's like easier to be honest with you. But if you want to go through like a no code version of this, you can also, that's some of the things that you can build using N8N, which I still think is really cool. Okay, so let's talk about agentic workflow patterns. So you already saw like some of the examples that the demos that I just showed you, right? So when you're building these, this is based upon like Anthropic. I think Anthropic has the best pattern, like this article is the best that I found in terms of showcasing like what kind of agentic workflow patterns that you want to have. So when we're building the workflows that I just showed you earlier, we were like, yeah, like when I built this app, I'm not just like, oh, like let me just randomly put things here and then hopefully it works, right? This actually follows like specific type of pattern. So I want to show you guys like the specific type of patterns that tend to work the best depending on what it is that you're trying to build as like multi-agent systems. So the first one is called like prompt chaining. And this is when prompt chaining decomposes a task into a sequence of steps where each LLM call processes the output of the previous one. You can add programmatic checks on any intermediate step. So this is when you have some sort of input, like you have some sort of request, you have your first LLM call where you can call it LM call. I tend to usually call it like your first sub agent that does something with the input. Here you have like a gate. You don't need to have a gate, but you can have like some sort of gate that fails if depending on what the output is, but then you basically just pass it along to whatever the output is. You pass along this output to the next LM call or sub agent, and then the next sub agent does something, and then it passes on to the next sub agent, and then eventually you have a final output that's there. This is especially useful when you have situations where the task can be easily and cleanly decomposed into fixed subtasks. Some examples of when you want to do prompt chaining is if you're generating marketing copy, then translating it into a different language, or writing an outline for a document, checking that the outline meets certain criteria, then writing a document based on the outline. So you're kind of like, does that make sense? You're kind of like 1, 2, 3. Something that you can decompose into different steps. You usually want to use and implement this type of workflow, this type of agentic workflow. The next type of workflow is for routing. So routing is when you have a certain input and then you have a specialized sub agent that takes the input and then decides like which route it should give it to. So each of these sub agents, like LM call sub agent 1, 2, and 3, specializes in a certain thing, and your routing sub agent will decide which of the inputs, like sorry, let me rephrase that. It will decide to give that task to one of these different sub-agents that it thinks is best specialized in. And then whichever one it is specialized in, it would have like an output after that. And then, yeah, so an example of this would be, say if you're having something that is for customer service queries, for example. So maybe you have like general questions, refund requests, or technical support. So your inquiry that's coming in, it might be like, I want refund. And then your router sub agent will be just like, okay, this is great. It should go into like the payment processing sub agent. So maybe it would go to this one and then you have an output. But maybe like another query would be something like, I don't know how to log in because I cannot find the button, right? Then it would probably route this request to another sub agent that specializes in technical support, and then which would be able to do whatever it is that it needs to do to provide the output. Okay, and the next one is parallelization. I can never pronounce this correctly. So parallelization is when you want something to work simultaneously on a task and have their outputs aggregate programmatically. So it's basically like you want to choose two variations to this. Like sectioning is when you break a task into independent subtasks, run it in parallel to make it faster. Or voting is when you run the same task multiple times to get diverse outputs and you aggregate it together. So you basically have some sort of input, you have different sub-agents doing whatever it is all at the same time, aggregates everything together, and you get a final output. Some examples of this would be when you're implementing guardrails, where one model instance will process a user query while another one is screening for inappropriate content or requests. So you're able to do these things in parallel at the same time. Or say if you're like evaluating a performance of a model, some of it, one sub agent might be evaluating it for like speed, right? And another one might be evaluating it for accuracy, and another one might be evaluating it for I don't know, precision, something like that. Now some other examples of voting is you have like a piece of code for vulnerabilities, and you will have the sub agents, all of them would be reviewing, going through it, and flagging the code, and then eventually you can aggregate it together. So it kind of is like a voting process to decide if ultimately the piece of code is actually vulnerable or not vulnerable. So here's some examples of this. And I actually want to show you guys this go back here. I want to see if you guys can figure out which one is which. So the one that I showed you earlier, the AI news one, type in the comments. I think I already said it earlier, but maybe you weren't paying attention. What kind of workflow do you believe this is? I shall wait for you guys to respond. Hi, do you need programming knowledge to get an AI agents? Nope, you do not. So that's actually why I'm showing you guys this no code example right now using NA to N. I think the key is to understand just the theory behind it. Like I was talking about the components and the stuff and the different workflows, right? Because like coding is just the implementation of these concepts, right? And there's a lot of ways that you can use to implement these concepts. It's more important for you actually to know what it is that you're implementing first. Obviously, like coded versions for things is going to have a lot of benefits compared to like no code tools, but even if you're using no code tools, you can still get a lot out of it. Yay! Parallelization. Very good. I am proud of you guys. Wonderful. Okay, cool. And what about, maybe I'll go through the rest of it. Maybe I'll go through the rest of it first so I can confuse you guys. No, I'm kidding. Okay, so which one do you think this is? The one that I showed you about the multi-input daily expense tracker. Which one do you think that was? I'll show you guys like the different ones. So we have prompt chaining, routing, and parallelization. There's like other ones that are here as well, but I'm not gonna, these are like a little bit more complex. Which of these things do you think it is? Can you tell me how long it takes to create AI agents? Honestly, if you're doing it through code, it takes about like an hour or two. I actually feel like for no code, it takes so much longer. Like to create these ones, right? It freaking take like a really long time, probably like 4 or 5 hours. And the reason is not because like it's complex. It's just because when you're using no code stuff, you just end up having like dumb issues happen sometimes when you cannot connect an API key. You're like, oh shit. Or, you know, what we saw earlier, right? Like I had to like put in these like authenticator keys and I like don't know where to find them. And I had to like figure that out along the way. It's, yeah, like, I don't know. In comparison, I always prefer coded examples just because it's so much, like once you get it to run, it's a lot more reliable. But technically speaking, you can get something like this up really quickly if you're using one of their pre-built templates. It just becomes a lot harder to implement using a no-code tool, and it would take like 4 or 5 hours, maybe even more, because the ones I'm showing you guys right now, they're more custom made. So I didn't really, yeah, like the way we made it for in terms of like most of the time within the clients that we work with as well, like we don't do it just like based upon a template. Like you would actually have to go and create your own workflow as well. Yay! Routing. Very good. Wonderful. See, you have over here the trigger. It is able to go from text, voice to image. So it routes to different things depending on the type of input that you're putting into WhatsApp. And then it's able to process it separately and aggregates everything together. And in this case, you also had static memory that's being built in as well. So it's actually storing things into, oh, I don't think you can actually see that because my face is in the way. Okay, yeah, so you also have static memory. So it's actually storing things into Google Sheets as well. And yeah, so this is an example of routing. Wonderful. Okay, so a few other examples here are orchestrator workers. So this one is a little bit more complex, and this is, it kind of looks very similar. You can probably say like to parallelization or to like routing, right? Like because it kind of looks like this, but this is actually usually more suitable for complex tasks where you can't predict the subtask needed. So for example, in coding, the number of files that need to be changed and the nature of the change in each file likely depends on the task itself. So the orchestrator actually like divides this up, and you don't actually know like what kinds of different subagents, like what kind of calls that you actually require. And it has to like dynamically break the task down, and it's not a predefined version of which task it is. Like for example, the multi-agent system, the daily expenses tracker, it was very predefined that it was either text, voice, or image, right? But maybe it's not, and there's like other things that you need to do. So it has to dynamically be able to delegate the different types. And then you also have a synthesizer AI agent after that that's able to take all the things together and have some sort of output. Also, another thing, just general, this is like going from simple, like I would say like first three, like prompt chaining, routing, and parallelization are considered to be really simple ones. And if you want to, you generally want to default to one of these like more simple workflows if you can. And you only want to increase your complexity and do something like more fancy if it requires it to. So always default to the simplest version of what you can build. And also the next one, evaluator optimizer, gets even more complex. So in this case, you have one LM call generates a response, while another provides evaluation and feedback in a loop. So you have an input, you have a sub agent that generates something, has a solution, and you have like another sub agent that evaluates the solution, and then it'll give it feedback, and it'll just keep going on in a loop until at some point the evaluator sub agent thinks that whatever the solution is coming in is good enough, and then it would be accepted, and you have an output after that. Some examples of when this is useful is literary translations, where there are nuances that the translator LM might not capture initially, but where an evaluator LM can provide useful critiques. So you would have like, so maybe you have like a very nuanced translation, and then it's like not that good, and it will just keep on doing that until it gets to something that's good enough. Another example is complex search tasks that requires multiple rounds of searching and analysis to gather comprehensive information, where the evaluator decides whether further searches are warranted. The key thing if you're using an evaluator optimizer kind of workflow is that you need to make sure that you have a very good evaluation criteria, right? Because if you need to know like what is considered to be good enough in order to be accepted. And finally, the autonomous agent. So this is when you get to like the truly autonomous sort of thing. And this is something that there's a lot of research and innovation that's still happening in this area. The implementation is actually very, very simple in this case, but it is very complex in terms of what actually happens. So in this case, you have a human that would just say something to the agent, and then the agent would just have to like somehow figure out what the actions are, and then interact with the environment, get feedback from the environment, and keep on doing this. And just pretty much like it has full access to all tools. It can even create its own sub agents. You know, it can do whatever it is that it needs to do in order to finally have some sort of stop criteria to give you the final result. It's like very, very not well defined, because you're assuming that your agent, first of all, it needs to like choose the right path to do things, and it also needs to get feedback from the environment by itself. So since there's no like actual criteria for what it is that it's trying to get, like you don't give it any direct feedback. Like your agent has to kind of determine what the feedback is, whether it's good enough, and when it is that has to stop as well. So this is really useful for open-ended problems where it's difficult or impossible to predict the required number of steps, and where you can't hard code a fixed path. So some examples of this would be a coding agent to resolve certain sweep bench tasks, which involves edits to many files based on task description, or Anthropic's computer use reference implementation, where Claude uses a computer to accomplish tasks. You can see that this is an example of when you have this like autonomous agent system, and you kind of just let it do whatever it wants, right? So the human just says like, oh, I have like this query, and then your LLM is basically going back and forth, like with a bunch of different clarifying, refining, sending context. It's interacting with the environment many, many times, right? Doing a bunch of things until it finally decides that for some reason that it thinks is good enough, and it will send back the information. Sometimes you can get really good results from this. Well, other times you can get really shitty results. It really depends on like what the path the agent takes. Like sometimes you're able to get something that's like surprisingly good, but if your AI agent goes off on the wrong track and it does something and it just like completely goes off on the wrong track, it's very hard to redirect it back to what it's supposed to do. Also, like when you're creating something that's this autonomous, you also want to make sure that you're setting limits to it, because it can have like so many different calls, right? Like so many different calls to different APIs, so many different tools that's being used, so many different like model calls as well. So you can incur some like pretty hideous costs, I would say, if you're not being like very, very careful with implementing an autonomous solution. So you only do this autonomous solution if it's something that you want to be like very, very creative in terms of implementation, and make sure if you're creating this kind of autonomous solution that you're doing it in a way that is very well defined, so it doesn't go and do something crazy. If you want to do something like this also, I think it's quite hard to do using a no-code tool, really. So if you want to do something more advanced, generally speaking, it's much better to be able to use code tools to do that, so that you can actually set the guardrails and stuff properly. Right in the chat, the term agents. I want to see if You guys are, if, right, agents, if you followed everything that we just went through right now about the different workflows. I shall wait. Agents, yay! Okay, wonderful. Is Manus an autonomous agent? That's a great question. We don't really know because we don't technically know exactly what's going on there. It claims to be an autonomous agent, but maybe it's implemented using like a lot of different multi-agent systems to get that autonomous finish. Is very hard to tell, but it claims to be an autonomous agent. Like it acts like an autonomous agent. Agents, slowly picking it up. Agents, but there are a lot of questions people have. Okay. I will try to answer some of these questions. Would autonomous agent be an example of Cursor, Windsurf, or other? Yeah, Cursor and Windsurf, so those would be coding AI agents, and I think they are more autonomous. I would consider them not to be like truly autonomous because you're still giving them feedback, right? So in that case, it would actually be more in the sense of, what's it called? I forgot the name of it. It would be more like an evaluator optimizer instead of truly autonomous because you are giving it information and then you're basically giving it feedback over time until you finally accept the code solution, right? So I think it's more that, although it does have more like true agent behavior as well because it does interact with the environment directly. I think if you put on YOLO mode, it's more on autonomous agent, but if you're not doing YOLO mode, it's more on the evaluator optimizer side of things. Okay, I actually did also want to tell you guys that we are actually launching an AI agents bootcamp where we'll be teaching you all of these things and then also how to build them. So we'll be building like much more robust agent systems, multi-agent systems, going into a lot more detail about these things and also more sort of like, these are more like demos that I'm showing you guys, but during the agent bootcamp, you'll actually be building things that are productionized, things that can be released into the public. If you're either building your own startup, you want to freelance, where you want to learn about agents for your job and things like that. So it's a 4-week program and we haven't actually opened up yet, but I do have the wait list. And currently we already have around like, I think 1,600, 1,700 people already. So which is kind of crazy. So we haven't opened it yet, but we're actually only accepting 100 people in total because I just want to make sure that everybody that does join, like we want to make sure everybody gets the best experience possible, right? It's like a very personalized experience as well, where you're joining the different sessions, where you're going to be building out your stuff. You're going to have mentors that are going to be mentoring you and teaching you as well. So that's why we're only going to have 100 people, so everybody gets the amount of time that they deserve to have. So that's why I would say do join the waitlist because we're going to be opening up the waitlist in a few days, and the people on the waitlist will get priority to be able to join the agent bootcamp. And after we sell out from there, then that's it. We're only taking 100 people in total. So if you're interested in learning more about building AI agents and actually wanting to implement it and have the guidance to make sure you're implementing it at a quality that is suitable for like actually being used with your business, by yourself, or with your team, then I would recommend checking it out. And I will send you guys this link over here, and you have, if you're on the wait list, then you would get an email when we actually open up the signups, and you would have first priority in order to sign up as well if you want. Where is the thing? You can like sign up, join the waitlist for AI agents bootcamp here. This was mostly inspired just by the fact that I'm like making a lot of these AI agents work live streams and also videos, and I realized there's a lot of interest in them. And since we've been building them for, oh thanks Rex, a significant amount of time, we built them for clients, we built them for ourselves. We do consulting with AI agents as well. So we thought, you know what, let us actually create an AI agents bootcamp for people who are interested in being more serious about implementing these AI agents. And yeah, the way that I designed it is actually we kept in mind that there are people that are going to be no code people, also code people. So the way that I do things, I think you probably can tell by now, like the way that I see things is much better. Instead of just showing you like tutorials and demos of things, I try to give you the foundational information of how to actually go about thinking about implementing an AI agent system or a multi-agent system, and then we would then balance that out, of course, with the actual implementation. So the implementations, that the projects that you'll be doing, you always have an option to have a no code option. You also have a code option, so you can do one the other, or you can do both if you're interested in trying out something with a little bit more code. So it's also for people who maybe are not very comfortable with code, maybe you just want to like experiment a little bit on the coded side. That's also great for you as well, because we would have a lot of teachers and mentors to guide you through the process of implementing it through both. Or, you also you can do it completely through code if you're comfortable with code, and you can also completely not do it through code as well. So all of those options are available. Cool. Yeah, we try to make it very accessible, but also make sure that whatever that it is that you're building, either through code or through no code, or any combination of both, is something that is actually useful and is production quality, not just like a demo or a tutorial version, like something that you can actually use either for yourself, for your own business, for your team, as a freelancer as well. Which, by the way, there's actually like, we've been getting a lot of freelance requests, like our team specifically, and it's actually been pretty great, because a lot of people want to implement AI agents, but they don't really know how to do that. So yeah, like all the companies are like, we want to build AI agents. They don't actually know how to do that, and they don't really know people who know how to do that as well. So it's actually a pretty in-demand skill these days. Anyways, okay, thank you all so much for joining. Do check it out if you're interested, and also I'm gonna put the workshop thing as well here if you want the slides afterwards. I will, if you sign up here, I'll also show you the slides. I will send you guys the slides, and you can go through the things that we covered today as well. Cool. All right. Thank you all so much for joining, and I will see you guys in the next video or live stream. See you.